Sorry, my kind of Zoom hung for some reason. Let me share. All right.
Okay.
All right. So overall update, right? We had. Should we start now, or are we waiting for somebody?
Yeah, we can start now.
Okay. So we started on this project when we moved, project from Azure, which was called Kubernetes Policy Controller, to OPA library, so that everybody from the community can collaborate on it. That was the first goal. And the project saw initial interest, and it was kind of pulled together very quickly. So we basically, after we kind of put it in OPA, we are kind of going through a redesign phase of how exactly policy should look like. A lot of contributions from Google as well, and from obviously from OPA folks who have been kind of driving this. We last 1 month we have been having some kind of design discussions around what the policy should look like, how can we make the policies easy to be kind of created from an administrative perspective, and how can they be managed on a Kubernetes cluster. And then on top of that, we're trying to define the MVP for the project, and agree on the MVP. So I think we are at that stage where we have kind of agreed. Torrin can correct me if I'm wrong. Agreed on the high level goals for the project for the MVP, and our MVP is kind of Barcelona KubeCon timeframe. So that's when we think we will be able to announce something the way customers can start using them, trying it out. And based on the initial feedback, we will kind of enhance that, and then we'll add more features. So some of the features that we are going to planning to support is like validation scenarios, essentially policies, and then a policy library, which is more manageable, constraint-driven design. And so there are details on, if people are interested to go on, go to the issues, and there are like bunch of documents for different kind of proposals. There's MVP proposal, and there is a audit design proposal. There's policy library proposal documents, and a bunch of that. And then yesterday, Max from Google actually created, as of yesterday, like a document kind of describes the overall architecture, which I think is kind of very good to kind of visualize how everything will look, which is also shared publicly. And I don't want to steal the thunder from Max specifically, since he's not here. He actually worked on this entire document. It kind of, for sharing perspective, this was the whole idea of creating this document, that we'd be able to share it with people. Yeah, I don't have any specific demo for the new project, but I just have like update on the direction. I think the things that we have achieved is like V team that is now kind of strategically working towards a goal. I think that's the update essentially.
So can you illustrate, for example, 2 or 3 items that you think will be the biggest difference from the original Kubernetes policy controller
Right.
design?
So you are aware of Open Policy Agent, right?
Yeah, of course.
So Open Policy Agent provides the backend for, hey, kind of a deferred policy result, to say, hey, these are the data items, and based on that, based on the requests, whether it's yay or nay from validation perspective. Essentially, this is, if you can look at the diagram, this is the OPA block, and Gatekeeper essentially sits on top as a client to OPA, which will serve as admission controller. in addition, it will have these controllers which will manage essentially the policies on top of it to kind of, it's a CRD driven design. So you can define constraints which kind of encapsulate the policy itself, which is more like parameterized, and the controllers are responsible to kind of maintain its state with OPA on saying which constraints are applicable to what namespaces, what conditions, and so on. And then there's a block that kind of is exposing the audit functionality specifically to say in any point in time what are the current policies that are failing, right, for compliance results reason. So for the MVP, we are planning to do the admission webhook, not the mutation. Mutation probably will be supported as flight only. It depends on where we get at towards it's like a P2. But from the very basic feature perspective, it will be a validation webhook and with audit functionality available with full RBAC support on this. Yeah, there are documents where people can go and provide more feedback, or we have a Tuesday sync especially for this project at 2:00, and the details are available on the repository, the Slack channel, and so on. Any questions or any specific things that you want me to cover?
I think another thing I'm interested in is you guys currently have the policy library kind of design. Can you talk about that a little bit?
Yeah, actually, Torin is the person who designed it, and since he's here, I would ask talk about it.
Oh, sure. Yeah, I guess if you go back to that last that diagram, I can just speak to that, I guess, a little bit.
My Zoom hangs every now and then. 1 second.
It's annoying.
All right, come on. Sung. My calendar. It's not clickable for some reason. Yeah.
The Google product isn't working on a Linux laptop operated by a Microsoft employee.
I think
I can just speak to it. I mean, so yeah, maybe if you can find the doc, it would be useful. But
Kubernetes policy.
So at a high level, one of the things that the project includes. Oh, here we go. Great.
Yeah.
One of the things that the project includes is this notion of a constraint and a constraint template. So a constraint is basically like a set of parameters that an admin can define that are given to a well-defined policy. So like, for example, there are all kinds of policies that are super common that you don't need to like implement the actual logic for every time in every single organization, right? So for example, if you want to like have a policy that requires certain labels exist on all Kubernetes resources, the logic that enforces that or makes that decision about whether the required labels have been supplied is fairly general. It's not very organization specific, and it's something that could be like encapsulated and shared and reused as part of a common library. And so what the constraints are sets of parameters that parameterize that logic. So the idea being that you can write this logic once. You can write a policy about required labels or a whitelisting of say image registries or something like that, or what have you. And you can publish that logic in the form of what we're calling here constraint templates on say GitHub, right? And then what you can do is you can instantiate those constraint templates with a set of parameters, and we call that set of parameters constraints, in order to kind of like tune the behavioral logic or to parameterize the logic, right? So the library that we envision is basically a library of these constraint templates, these bits of Rego policy that that just encapsulate, common policy use cases like requiring certain labels, whitelisting image registries, whitelisting, ingress host names, you know, setting up, a deny list for, certain container capabilities or, scheduler, capabilities or things like that, right? So there are all kinds of these policies that are fairly common. They don't differ wildly across different organizations. And so the idea being we can just have this logic in a central place, and then make it such that an administrator that wants to instantiate that policy doesn't have to actually know the details of the logic, but they can just like provide a set of parameters to the logic to kind of like set the actual host name of the registry, for example, right? Or to set the set of labels that are needed for Kubernetes resources, right? So that's kind of it at a high level. We don't have the actual library like developed yet. What we were doing in the last month was deciding how the policies that make up that library should look. And so that was mostly just about like, how should you actually write the Rego? Like, what are the best practices around writing Rego, Opus policy language, that we want to kind of like instill or design around?
Yeah. So a lot of work that was being done is more about design, thought. The action is going to happen, execution is going to happen in the next 1 month and 2.
Yeah.
One thing, I think OPA is starting to take off a lot because of its flexibility. And that makes it so that people can write these policies in a way that they can understand and make sense for whatever their kind of, system is like. Whereas on the other hand, people hate dealing with RBAC or any of the native really policies in Kubernetes. It's really hard to reason about. So I'm just wondering why I feel like you're kind of moving away from what was one of the strengths to kind of fit into the Kubernetes world, where it was like, but maybe there was something that we would want to bring over from that more free form.
So did my comment about RBAC kind of trigger this question, or?
No, I mean, it's just like for all the policy discussions within Kubernetes, there's been lots of, how exactly do you specify, deny, allow, and compose? And in the meantime, while we're discussing this, people are out doing their own things, right? And their own policies, writing it however they need to for whatever their situation is.
Okay.
Yeah, and I guess like what we've seen with OPA is that like people, they both want the flexibility of that OPA provides, but then they also just want to kind of like get started really quickly in certain cases. And so this constraint template framework that we're talking about just kind of like assists that a little bit. It doesn't prevent people from writing like raw Rego that generates the decision that they need. Like they can still do that. It's just that it provides like a set of canned policies that are like, I don't want to say uninteresting, but just like super well known. Like you don't have to rewrite that, every single time. It just provides like a little thing to get started with. So it's not changing the way that you write the policies or making it particularly like domain aware. You're still using this domain agnostic system to. To
kind of complement that as well, is there are two kinds of administrators here, right? One, the first administrators actually who writes policies, and there are the second class who are consumer of these policies, but they want to enforce them on a cluster. So this project is about using already created foundation from defining the policies to actually implementing them in real clusters on cloud, say, for example, at a scale, for example, and things like that.
Yeah, I think it's a pretty interesting concept. I think it sort of similar to the parameter server in machine learning. So basically, it separates the parameter from the policy semantic. I think one of the potential could be like people live tuning the constraints. so that the policy could be like adaptive, right? To the I think it's quite interesting. And
there are other interesting features that have been discussed, like dry runs, right? You want to be able to get what happens if a policy is deployed
yeah,
on a running cluster, right?
yeah,
What is the result of that a priori before you actually apply them? So there is a lot of thoughts going on. It's not part of the MVP yet, but the foundation kind of allows of having constraints and parameters and a layer on top of the policies to kind of regulate and manage them effectively.
Yeah, Howard, if I can just maybe I just want to repeat what you just said, just to make sure I understood what you said correctly. So by formalizing like the parameter set that a policy can accept, that means that you can end up having things potentially other than administrators provisioning those parameters, right? You could end up having like systems that are configuring those parameters.
Yep.
You know, as a result of like a feedback loop or something like that. And so it opens up interesting automation.
That's kind of related to the like the policy across deep learning and the cloud system.
That's super interesting. We haven't
I will talk about it.
Definitely an interesting topic. Yeah.
Another question. So we also invited like project Cilium and also the Kubernetes storage SIG developer over. So do you guys think the current RIGO or open mechanism could also cover these, like for example, storage policies are not like restricted to like allow, doesn't allow, you know, those auth semantics, they have like reclaimed or whatever. So do you guys think the current mechanism is like extensible enough to support like those kind of resource-oriented policies?
So OPA itself is definitely capable of that.
Okay.
What we're trying to do with Gatekeeper is specifically around building up basically a set of constraints that say these are states that the system should never get into. So that's what and specifically for Kubernetes, right? So like OPA itself and OPA's language are not tied to like authorization semantics like allowed and I. Like that's totally when you see allow in an OPA policy, it's not special. It's just another name that you decide to give to a rule. So you can definitely write like policies that generate like non-Boolean decisions, for example.
Yeah. So another way to asking it is, are you guys seeing like Gatekeeper towards like a general policy controller for Kubernetes instead of just focusing on auth?
General admission controller is what you mentioned?
No, general policy controllers. For example, we can use it for identify whether the storage policy is enforced correctly, or the networking or security policies.
Or the IP addresses are firewalled and things like that, right? Yeah. I mean, there has definitely been interest from customers around those kind of scenarios which are data plane oriented or like config oriented, that may not be like control path policies, right? Is that correct? Is what you're trying to ask? They may not, their configurations on some state which is not being changed, but you want to have some kind of audit on is this currently sorry?
Yeah, what I'm asking is sort of like the resource-oriented policies, like for example, a QoS guarantee for a certain networking or storage, IOOps, you know, that kind of policy control.
It's currently not doing any data plane policy.
Okay. So
in the current design, it's not doing that.
Yeah, I know. So are you guys like looking at possibility of
No,
in the
there has
future?
been no specific discussion around. So we are currently very tightly scoped around admission
Okay.
controllers.
Okay.
Um, and that's the first thing to kind of, there are lots of variation within even admission controllers, right? So the current project is focused, but I know what you're mentioning is very interesting, and but it's not in scope, at least as it stands today. Paran can correct me.
Yeah, no, I mean, I think that Nikhil said it right. Like, we're focused on providing a really good experience for people that want to put constraints over arbitrary Kubernetes resources, right? So if you want to put
Yeah.
a constraint or an invariant or a guardrail or a rule or whatever you want to call it over network policy or over pods or over persistent volumes or over nodes or namespace objects or whatever that desired state is that goes into Kubernetes, Gatekeeper provides a good solution for that. If you want to enforce a policy like in the data plane of your network, like that's not Gatekeeper. If you want to enforce a policy in the API of the application that's running on top of Kubernetes, that's definitely not Gatekeeper, right? So I think the way to think about it is that it provides a system for enforcing constraints over desired state within Kubernetes.
Okay. So if not directly data planes policy, but like Kubernetes storage policy, would it be possible for Gatekeeper
There
to
are
handle?
scenarios. Yeah,
Okay.
there are scenarios about storage policy that are control plane, right? Those will be covered.
Yeah. So as
Yes.
long as is on the control plane, the Gatekeeper should be able to, in the foreseeable future, support the policy control, right?
Well, it should be able to do any validations as long as these objects are, are state that are stored in etcd.
Okay.
So there are two states that we really kind of focused on. One is the priority first priority is like in cluster API server state that API
Yeah.
server is kind of managing, right?
Yeah.
And then there is external data, which is like, hey, I'm a user and I want to get information about user context, which is external to Kubernetes, right? Which is interesting to customers because their Kubernetes cluster is running in some kind of a context external to Kubernetes. So that's the second scenario that we care about, but it's not part of MVP.
Okay.
I have to drop, folks. It was nice seeing you again, Howard and Erica. Yeah, we can follow up soon with more updates, but I'll let you guys continue.
Yeah.
Thanks for joining.
Yeah,
Thanks,
take care.
Howard.
Bye.
Okay. If I can like quickly summary, I think Gatekeeper so the core differences from the previous Kubernetes policy controller is that currently you will have the data controller and the template controller, right? That those are were not like included in the original design, and you have the audit controller, which was in the original design.
Yeah, it was in the design, the CRD, but it wasn't implemented.
Yeah. Okay.
And now we have even more interesting controller design, which is introduced by Google, folks from Google, about how do we actually categorize administrators, right? The initial design was about, hey, we'll have a CRD based policy definition, which is manageable, which is like R backable and things like that. But now with the constraints, you can actually categorize them saying, hey, this is a storage administrator who can manage these classes of policies. This is like a network administrator manages blah policies, right? So now with this design, you can actually do much more like deeper level. And then there is a story around GitOps and how do you kind of create a client library which can help you manage these policies as well.
Okay, interesting.
Yeah, one of my questions is, I'm wondering from the provider perspective, we would like to put things in the cluster itself because then we can distribute it to everyone. Whereas in reality, the heavy pieces of policy are probably like in the CI/CD, in the CD platform for most users. Really, that's kind of their where their gates are, and that's separate from the cluster.
Right. Yeah. There's a scenario. Yeah. So we are planning to expose a library where you can run these policies at your CD pipeline as well, with not just runtime in the cluster. So this idea came from, actually we borrowed the name from there was another project called Gatekeeper that was being run by Replicated, and right, so they donated the name.
Okay.
And kind of everybody's working together now on this one single project. So they had this idea about like CI/CD and being able to do like exactly what Erica mentioned, right? Like be able to do validation a priori, actually not at runtime. Yeah, so that's something in plans as well.
Cool.
Yeah, because I've seen people, or there was a presentation on Spinnaker, I forget which company, Grubhub, I think. Anyway, they were making so many pipelines that they needed to have policies, which they have policies within it, and then they needed policies and parameterization on the CI or CD pipelines. So they would have policies on top of the policies.
Yeah.
There's several layers at this point.
By the way, I like the book that you have behind you.
This one?
Yeah.
Yeah, I'm pretty excited about it. Just came out. That is another.
Who's the author of it? Sorry to diverge. I couldn't.
No, it's okay.
Even oh, nice. Looks interesting.
Yeah, it's has some math, but it's not overly mathy. So, which does remind me, the other, when you're talking about constraints on the cluster, it reminds me a lot of systems modeling. I was just wondering if there's something we could take there.
So by systems modeling, you mean like you want to be able to inherit some of these systems and apply them on different systems and be able to reapply them, or like?
One of the problems that makes policy hard right now within clusters is that the systems are so dynamic, and really until you play it forward a while, you won't find what's wrong with it.
Yeah.
Right, and it's things about cycles and kind of race conditions and that sort of thing, and those are a big class of what you can prevent.
Right.
As well. You're always kind of dealing with the time dimension that we tend to try to get rid of, but really is something that's omnipresent within clusters.
So what you're saying is that you don't know the policy that you need to apply beforehand because you'll find those issues later.
Yes, often.
And you so so you basically have some kind of idea of guiding principles of saying this is how the cluster should behave, right? So you want to define some kind of rules of operation for your users as well as for expected state in Kubernetes.
Yes.
Right? So we try to address that through policies, right? And express that to policies. And the thing that we are, I think we are not kind of going to predict what will happen in future. Like we don't do that. But what we are doing is we are trying to create these kind of templates that are experiences from expert Kubernetes operators, right? That new Kubernetes users can directly apply, of saying this will make your bread and butter policy, right? So that they don't have to actually go and sweat it out, find issues later after they start using Kubernetes, because these policies are like well known to kind of save you. Like your registry should come from your image should come from your registry, right? Very like simple policies that if followed, will make your cluster more secure and more manageable. From that perspective, yes, I think this project tries to solve that problem more holistically, and then also kind of providing power to the administrator um, um, to be more knowledgeable about Kubernetes without actually having to spend too much time. If that makes sense.
Sure.
Okay.
One
So
nit.
yeah.
Oh, I was just gonna say one nit. At least there's a large backlash against templating, especially within Kubernetes, I believe. And I just might, for publicity, just maybe consider renaming it.
There's nothing called as template. I'm just kind of using that language. It's like a labeled set of policies, right? That you would say these are HIPAA compliant, right? So it's a collection rather than any template that would make, possibly we'll label them, and then there's a library that will go and apply them from the source to say these are the policies that form a group that is labeled as HIPAA. I'm just giving an example, random example.
Yeah. Do the policies kind of compile down to something, or are they constantly grabbed and recomposed for
Yes.
every kind of request?
So the policies are rebuilt. So we have so there are two artifacts. One is the rego, and one is the parameters. Right, there are two separate artifacts.
Sure.
They kind of combine themselves to become like CRDs, right? CRD definitions, and there'll be another set which will be labels, right? Which is like these grouping concept of saying this policy and this policy can form a logical group of HIPAA compliant or something like that. And then when somebody goes and says apply HIPAA compliant policies and basically picks the policies, groups them together, applies them on a cluster.
How do you choose order of operations?
These are independent policies. Mutation is not currently supported, right?
Sure, but you could still have one that would give you one answer and another that would give you another, and therefore
right. So,
they don't necessarily.
So there is no current. There was ideas about static analysis of being able to look at the data from the Kubernetes cluster and say that, hey, these are violations, where one policy would say yay, the other one will say nay, right? And based on the ordering of how they get called, API server will basically behave like randomly. Yeah. So I think at this point we don't solve that problem, but this is something I believe is solvable from the design. Is like understanding based on the current state of the cluster, you should be able to say all of these policies are immutable in sense that they are order independent.
Yeah.
Logically.
Yeah, it's something you might want to think about earlier than later. It's a big tech debt later to try to add it on. We're finding in with pod security policies especially.
Yeah, good point.
Yeah.
And could you also help put the document link on the meeting notes so that we can track it? The architecture.
There are a bunch of documents. Should I just put the architecture document there?
Yeah,
there are documents around policy library. There are documents for audit. There are documents for like the constraint templates. There's overall architecture document. So I can put all four of them.
Okay, cool. Okay, thank you so much. So if you still have time, you can hang around. So next I'm gonna talk about something I just came out yesterday, I think. Let me share the screen. So I think last couple of meetings we mentioned there's like big policy concept in the reinforcement learning and see if there's anything related. I was just listen to the Trimo, This Week in Machine Learning podcast the other day. There was an episode discussed the Facebook spiral system, which is super interesting. So that was what drive me to form this little presentation. So I'm not ML expert, so bear with me on the theory of complex systems. Okay, so I would presume I think most people are familiar with the basic concept of the machine learning at the moment. So what we are like being like buried with all the hypes these days, most of them are like supervised learnings on images or audios, videos, whatever. So this is the typical machine learning stuff uh, everyone is talking about. So the other thing is the reinforcement learning. So I think architecturally there's not like huge difference, but so I think one of the core difference is that when we do the traditional supervised learning, what corrects the prediction is the human noted like the true results of that sample. But for reinforcement learning, it actually learn from the sample, but get corrected by the the real consequences from the real world. So that's kind of like the core difference. Okay, by the way, this the slides are from the MIT's deep learning course, which is pretty awesome. So
the slides look awesome.
yeah, so reinforcement learning, I think one of the most popular example are like AlphaGo, right? Playing Go, or I think UC Berkeley are doing a lot of the robotic support by reinforcement learning. So there are like different kinds of RL mechanism. So I think what we are interested are policy-based RL mechanisms. So I will be focusing on this area. So kind of like this branch, right? AlphaZero, those are mostly model-based, so it's not policy-based.
So when you say policy based, it's basically certain rules that will basically allow choosing which module to run, or like how?
Yeah, well, to my understanding, what policy-based means is that your whole neural network are trained to like optimize your policy gradient to find a optimal policy. But model-based or non-policy-based is so you build a model to modeling the environment sample, right, and to try to get the optimal model which will give you the best result. So that's kind of the difference as far as I can understand. Okay, so reinforcement learning policy is I think pretty straightforward. So we define a policy, basically formulates like how to act from a current state to the next state. So define this action with this policy so that we will be like anticipating a sort of optimal outcome. And for I think most of the time the policy are stochastic. So there are deterministic policies as well, but I think most of the academic work concentrating on the stochastic policy, which means that the policy is like have a probability distribution over the state. Okay. So this is what like formulate like how to optimize a policy. So you have a expectation to maximize the reward, and so these are the reward functions, and you have the probabilistic of the policy distributed over theta steps, I think. So the below function, this is the ultimate, like the policy function of, I think, overall reinforcement learning. So you, so as you can see, you have a model of the state given the action, and then you have the policy. This is apparently a stochastic policy to describe what steps you should take from the previous state to the next one to have a pretty good action result. And your whole neural network system are trained to like learn this to have the best result. So as you might recall, the leftist branch. So the policy-based reinforcement learning, most of it like concentrate on the policy gradient. So for example, DQN is like, or like Q-learning is has been a long concept in academic. So DQN is like indirectly infer the optimal policy, but for policy gradient or policy-based reinforcement learning is directly optimize the policy space. So like I mentioned, our whole neural network is being formed to model the policy itself. So we want to, well, there's a Jacobi, I think, function to describe the policy for the whole system. So again, we would like to maximize the likelihood of a return based upon the policy that the network is continuous learning. There are like other cans that I haven't covered. I think you guys could find it on the deep learning MIT slide yourself. So there are like A2C, A3C. So it's basically replace this part of the function with like it's called actor critic, I think, model. So you run two set of actions and do the comparison. Another area is what they call the policy optimization. But all in all, so it's just about how to optimize the reinforcement learning policy gradient. Like if you pick the step size, then pick the direction, maybe could be like better performed or less biased towards some result. Okay, I find, well, I Googled some example. So the most basic one is the grid game, right? It's the most simple one. So here you will have mostly a deterministic policy. So you have steps, you have reward, you try to have the maximum reward outcome. So this is a Jupyter notebook defining the policy. So you can have, for example, random choice, right? Or two choice random. And you can come up with a initial policy, and then you can add in noise to it to start training the policy. The classical policy gradient example is by Andrew Karpathy, now the head of AI in Tesla, the ping pong game. So basically, you formulating a network to describe the policy as shown here, and train them with the different result, and over time it will learn. So this is one of the example, the source code using TensorFlow to define the policy as a neural network. The third example is there's a UC Berkeley project for distributed reinforcement learning called Ray. They have a RL library component, which is very interesting. They try to abstract away like different frameworks for reinforcement learning. And they have this concept of policy graph. So I think at the moment they only have the TF ones, but they're supposed to have the PyTorch ones, I think. So policy graph is an abstract like policy API to like interact with different deep learning frameworks with their own like policy definitions. Okay, case study. So Facebook Spiral is I don't think it's open source yet. So it's a machine learning based self-tuning system for Facebook. One of the motivation for them to do that is Facebook claim that like every few hours you are basically using a new Facebook, right? So they are updating their application system quite frequently, and you can't do that like manually to support that. So they developed Spiral to utilize machine learning to help a lot of the tuning and configuration for the front end. I think this is the most interesting paragraph for me from the blog post. So there are classical use cases for caching policy. So they are applying like reinforcement learning for the cache eviction, and they use the cache metadata as feature. Grab those metadata from system and associate labels, feedbacks to those metadata. For example, these kind of pictures are not like used by the user frequently. Maybe we should not cache them. So together they form a classifier. So the classifier is used to make decisions. So the classifier is sort of like the policy neural network we talked about. This figure actually from Dan Lu's one of his blog posts, I think very interesting about the cache eviction. So for very general system-wise cache eviction policy, I think what they find out is that using random, well, two choice random are very optimistic. Also RRU. It's pretty good. But I think what Spiral does is a little bit specific down to like the images or the videos the user either like uploading or viewing, like which items I should cache, which are not. So this is, I think, very similar to the Greek game. Right? You have random choice. So final thoughts. I think there are like 3 aspects that deep reinforcement learning could have correlations with the cloud native system. So the first one is like Spiral, right? You apply the reinforcement learning to your cloud system. For example, either on data plane, right, cache policy, network policy, or control plane, scheduling policy. The second way is to build a cloud native system to support deep reinforcement learning. We have Kubeflow running on Kubernetes at the moment, right? Support TensorFlow, PyTorch. So it will be like that. So the policy-based method requires typically more samples. So it means the policy-based reinforcement learning are data and compute, possibly network intensive. So depending on the complexity of the policy gradient computation, the cloud native system should be able to select the best fit node. This should be defined also by a policy to run those reinforcement learning jobs, right? The third one, I think, would be the most interesting one, and also have something to do with the parameter or the template library the Gatekeeper project has designed, is like actually correlate the policy across the cloud and reinforcement learning jobs. Say we have a big cluster, we have application pods, we have pods that doing the reinforcement learning serving, right, for those applications. For example, the reinforcement learning pod, what they serve are the specific cache eviction policies, like what Spiral do, right? And then the problem for the cloud or the cloud native system is we have a policy that specify obviously a scheduling policy to tell the pod to run on the node that are like comply to the DRL policy that are constantly served. So I think this would be a like very interesting correlation we can see.
Cool.
Yep, that'll be all.
Very informative. I'm absolutely new to this area. Yeah.
It's definitely a buzzword like thing where you hear a lot about using AI to detect threats kind of thing, you know,
Yep.
A lot of startups. But it does sort of answer my question of, you know, you have a lot of data or different information across the state at the cluster or whatever, your system at a time. It takes resources and time to compute policies based on that, at which case it might not be accurate anymore. So you have to compress that information and do it probabilistically.
Yeah.
Yeah, I think it kind of answered the question you were asking me.
I think so.
Yeah, exactly. It's very interesting of how machine learning can be applied to policies, right?
Yeah.
And maybe we will see, like, we can do training for the gatekeepers, like policy parameter.
Yeah, it's very much possible. I think more I think about it,
Tune them.
like people should not have to write policies. It's like when you're driving on the road, you cannot tell them everything that's possible failure case, right? you want to be able to say, you want a system to infer what is right and what is wrong. So I think inference from deep learning and machine learning can possibly be one of the future policy engines, right?
Yeah. Okay, that's from my side. So, anything else we want to discuss today?
I am deep in thinking about this stuff. I can't remember any practical things we should talk about.
Cool, folks. I will take a lead now.
Okay. I
All right.
think
Thank you so much for the opportunity to kind of invite me to talk about Gatekeeper.
yeah.
And thanks for your feedback as well, right? I will bring that up to the community, especially the one that Erica mentioned about the sequencing and making sure that that's kind of considered.
Yeah.
Well, thanks for coming and talking.
Yeah.
Thank you so much. Yeah.
I think
Bye.
we can conclude the meeting as well.
All right.
All right. See you guys next week.
Yeah.
Bye.
Possibly. Bye bye.